In this mini lecture we will discuss movement of toxic substances in the environment, their effect on the environment, risk assessment and risk management, and two different philosophical approaches to risk management. After reading chapter 14 and watching this video or reading the transcript that goes with this video, you should be able to explain the movement of toxic substances and how they affect organisms and ecosystems, evaluate risk assessment and risk management, compare philosophical approaches to risk and how they relate to regulator policy. Toxic substances affect ecosystems can have a cascading impact on an ecosystem's composition because there is a chain reaction when one species is adversely affected by a chemical. Thus toxic chemicals threaten ecosystem function. Toxins concentrate, persist, and travel in the environment in many ways. Chemicals can travel by air. They can impact areas far from the site where the chemical originated. Synthetic chemicals are found globally due to global distillation, which is the global atmospheric circulation of contaminants that moves pollutants to poles. For example, polychlorinated biphenyl or PCBs, chemicals once used in transformers and other electrical equipment in the US, are concentrated in Arctic polar bears, penguins, and people in Greenland due to global distillation. Another example of movement of chemicals is pesticide drift, or the airborne transport of pesticides. Toxins and toxicants can degrade quickly and become harmless, or they may remain unaltered and persist for months, years, or decades in the environment. Rates of degradation depend on the substance's chemistry and on factors like temperature, moisture, and sun exposure. Toxicants that do degrade will break down into simpler breakdown products. These products may be more or less harmful than the original substance. For example, the pesticide DDT degrades into DDE, which is also highly persistent and toxic. So in this case, degradation isn't helpful for the health of the environment. Synthetic chemicals can take many different routes as they travel through the environment. The take-home point from this figure is that you are exposed to low levels of chemicals in nearly all aspects of your life, so it is a good idea to be knowledgeable about what chemicals you could be potentially coming in contact with. In the 1960s, untested pesticides were indiscriminately sprayed with the assumption that they would not harm people. In 1962, Rachel Carson wrote Silent Spring and awakened the public to the risks the pesticide DDT posed to people, wildlife, and ecosystems. This bestseller generated social change in views and actions towards the environment. Largely as a result of Carson's book, DDT was banned in the US in 1973. However, DDT is still made in the US and exported to control diseases transmitted through insects such as mosquitoes. DDT is considered an excellent solution to the problem of malaria in many developing tropical countries. In these countries, malaria viewed as a greater risk than toxic effects of the pesticide. Some people call this a circle of poison in that we export DDT to developing nations and it is then possible that we could import DDT-laden food when we buy agricultural products from these nations. This poses the question, is it unethical for one country to sell others a substance that is deemed toxic? Or would it be unethical for the US to not sell DDT to African nations if they want to use it for controlling malaria? Toxicants can accumulate and biomagnify in the environment. Bioaccumulation is when fat-soluble toxicants build up in animal tissues. This means the animal's tissues has a greater concentration of the chemical than the environment around them. When this happens, the toxicants can travel through the food chain to other organisms. Organisms on all trophic levels bioaccumulate the substance in their tissues. At low trophic levels, the concentration of the contaminant may not be significant. However, the concentration of the contaminant in the bodies of organisms increase at higher trophic levels by the process of biomagnification. Biomagnification is the process by which toxicant concentrations increase at higher trophic levels. For example, as has been mentioned before, DDT was widely used in the 1950s and 1960s. It was banned because it was discovered that it traveled up the food chain and caused reproductive problems. The unhatched offspring of peregrine falcons and bald eagles were dying because DDT was making their eggs too thin and brittle. This caused the near extinction of peregrine falcons and bald eagles. Another example is PCBs and polar bear cubs who get it from their mother's milk. The cubs subsequently suffer immune suppression, hormone disruption and high mortality. Toxic ants threaten ecosystem services, change the composition of ecosystems, affect how organisms interact with each other and the environment, and threaten ecosystem services. Some, but not all chemicals, go through toxicity testing. The steps between collection and interpretation of toxicity data and development of policies to regulate the chemicals are referred to as risk assessment and risk management. Risk assessment is the quantitative measurement of risk. Risk assessment compares risks involved in different activities or substances. It identifies and outlines problems, and helps determine which substances and activities pose health threats to people or wildlife. Risk assessment has two steps. 1. Hazard identification and toxicity characterization, which is the scientific study of the chemical. Scientists would ask questions such as, does the substance have toxic effects? And, how do effects vary by exposure? This information comes from dose-response curves. 2. Assessing an individual or population's exposure to the substance or the extent of exposure. This process considers things such as frequency of exposure, concentration of exposure, and duration of exposure. Risk management are the decisions and strategies to minimize risk. In the U.S., the following federal agencies manage risk: Centers for Disease Control and Prevention, CDC, Environmental Protection Agency, EPA, Food and Drug Administration, FDA, and OSHA, Occupational Safety and Health Administration. In the formation of risk policy, scientific assessments are considered with economic, social, and political needs and values, and risk management includes cost and benefits analysis. In short, the steps to creating chemical policy are: 1. Toxicity testing. 2. Collection and interpretation of data. 3. Assessing and managing risk. 4. Formation of policy. There are two general approaches to managing risks. 1. Innocent until proven guilty approach, and 2. Precautionary principle. The innocent until proven guilty approach assumes a substance is harmless until it is shown to be harmful. This approach favors technological innovation and economic activity. The downside with this approach is that it allows substances which may be dangerous to be used. When this philosophy is followed, new substances are brought to the market relatively quickly. After limited testing, products reach consumers faster, but a fraction of them, represented in this slide by blue bottles, may cause harm to some fraction of the people. The precautionary principle assumes a substance is harmful until it is shown to be harmless. This approach identifies troublesome toxic ants before they are released into the environment, but using this philosophy may impede the pace of technology and economic advancement. This approach brings substances to the market cautiously, only after extensive testing. Products that reach the market should be safe, but perfectly safe products, represented here by purple bottles, will be delayed in reaching consumers. The philosophical approach taken obviously affects policy. The European Union largely follows the precautionary principle, while the US follows the innocent until proven guilty approach. In terms of chemical policy, the European Union has the REACH program, which stands for Registration, Evaluation, Authorization, and Restriction of Chemicals. This program shifts the burden of proof for safety to industry. Under REACH, 30,000 chemicals will have to be registered with the European Chemicals Agency. REACH will cost industry $3.8 to $7 billion over 11 years, however the health benefits will be $67 billion over 30 years. The U.S. on the other hand has the Toxic Substances Control Act of 1976. Under this law, the EPA monitors chemicals made in or imported into the U.S., which amounts to about 83,000 chemicals. The EPA can ban substances that pose excessive risk, but many health advocates think the law is too weak. Industry screening is minimal and the burden to prove the chemical is safe is on the government. This presents a vicious catch-22 scenario. To push for more testing, toxicity must already be proven, but testing is minimal to begin with. Consequently, only 10% of chemicals have been tested for toxicity and less than 1% are regulated. Almost none have been tested for endocrine, nervous, or immune system damage. For this reason, consumer choice is very important. Federal agencies involved in tracking and regulating synthetic chemicals include the FDA, which monitors food additives, cosmetics, drugs, medical devices; the EPA, which regulates pesticides and synthetic chemicals not covered by other laws; and OSHA, or the Occupational Safety and Health Administration, which regulates workplace hazards. That concludes the second mini lecture on environmental health and toxicology. If you haven't already done so, please watch part 1. Please review the weekly outline and complete the activities for this week per the schedule set forth in the outline.